Let's see what the question says. There is a corridor in a jail which is n units long. Given an array A of size n. The it index of this array is 0 if the light at it position is faulty, otherwise it is 1. All the lights are of specific power B, which if is placed at position x, it can light the corridor from x minus b plus 1 to x plus b minus 1. Initially all lights are off. Return the minimum number of lights to be turned on to light the whole corridor, or minus 1 if the whole corridor cannot be lighted. Let's understand with some test cases. For this test case, we have output 2, as we can turn on the lights at second and seventh index, then light at second index covers all lights indices from 1 to 5, and light at seventh index covers all lights indices from 6 to 8. For this test case, we have output minus 1, as there is no light which can light the first light of the corridor. Take 5 minutes and think about how can you solve it. Meanwhile, I take a small nap. Let's understand the best solution for this question. The best solution for this question is, for every light which is off, we have to just find the rightmost light which is on initially, which can be done by using 2 pointers. We can take 2 variables which can tell the indices of leftmost and rightmost lights. It can light up, and then, by using while loop, we can find the light which is on. If we don't get any light that is on, then we can simply return minus 1, as there will be no light which can turn on the current light. If we get a light which is on, then we can directly jump to index which is 1 greater than the rightmost light of that light, and repeat same steps until we get the answer. Let's dry run over some test cases. For this, in iteration 1, the variable r will be 2 and the variable l will be 0. This gives a window from L to R in which we have to find a light that is on. So we enter in while loop, and if A of R is on, then we can say that all lights from indices L to R can be turned on. So we directly jump to index R plus B, which makes the value of I equal to 5, and we increment the value of answer by 1. In iteration 2, similarly we get a window from indices 3rd to 7th. Again we enter in while loop to find if A of R is on, then we can say that all lights from indices L to R can be turned on. So we directly jump to index R plus B, which makes the value of I equal to 13. That exceeds the size of array, and we increment the value of answer by 1. This ends the for loop, and we get our final answer as 2. For this, in iteration 1, the variables L is equal to 0 and R is equal to 2. So we enter in while loop and check if A of R is on or not. In this case it is off, so we decrement the value of R by 1 and again check same condition.